Chemistry, this is the next lesson called Discovering the Atom. So, the Bohr model of the atom. An orbital is also called a shell, is an energy level at which electrons must stay. Electrons can pass from one orbital to another, but they cannot stay in between orbitals. Niels Bohr came up with the idea of circular orbitals about 100 years ago. You will learn later that the shape of the orbitals are much more complex than this. Electrons in orbitals further from the nucleus have more energy. Orbitals can be compared to steps on a ladder. You can climb up or down steps on a ladder, but you can't stand in between the steps on a ladder. So, discovery of the electron. In 1897, J.J. Thomson discovered the electron. Thomson placed a negative plate and a positive plate at opposite ends of a cathode ray tube, which caused a stream of electrons to move across the tube. By placing a magnet on the side of the tube, he caused the electrons to curve. He was able to determine both the mass and charge of the electrons. So the negative plate is over on the left side, so that's going to repel electrons because electrons are negative. Over on the right side is a positively charged plate, and that's going to attract the electrons. So they're going to form a stream from left to right. And what you're actually seeing there, number 3, this creates a visible stream of electrons in gas. That's an actual photograph. It's not just, so you're actually seeing electrons there. A magnet causes the negative electrons to change direction. Plum pudding model of the atom. In 1904, Thomson proposed a model of the atom that included electrons. He knew that there must be positive charge to balance the negative charge of the electron. He believed that positive charge was evenly distributed in a sphere with the electrons spread around the sphere. So you can see the model down there. The big pink sphere is positively charged, just evenly distributed, and in it are stuck a bunch of electrons. This model became known as the plum pudding model of the atom because it was a soft, solid sphere with chunks of electrons. Over on the right there you see, in England, pudding is not what we think of pudding as being. It's kind of a cake type of substance with spices. And so he had that pudding with pieces of plum stuck in it. So that's why it became known as the plum pudding model. In 1911, Ernst Rutherford performed his gold foil experiment. The experiment demonstrated 2 things. 1, an atom has a solid nucleus center, but that most of the atom is empty space. Rutherford shot alpha particles, positive charges, at a thin sheet of gold foil. If Thomson had been correct, the alpha particles would have shown a small deflection, but pretty much would have gone straight through the gold foil. In fact, most showed no deflection, and some bounced back. This indicated that there was something solid inside of that gold foil, and that was a solid nucleus surrounded by empty space. So here's kind of an image of what's going on there. These little red dots are alpha particles. Most of them fly right by a gold nucleus. If one comes close to it, it'll curve. It'll be repelled because the nucleus is a positive charge. It has protons, and the alpha particles have protons. They have a positive charge, so they'll be repelled and they'll kind of curve away. But occasionally, and this was shocking to Rutherford, occasionally one would bounce straight back. So that told him that there must be something solid in there. He likened it to shooting a bullet at a piece of tissue paper and having the bullet bounce back. It was very shocking to him for this to happen. So positively charged alpha particle, most miss. Some come close and are deflected by the positive gold nucleus. A few hit the nucleus directly and bounce back. The discovery of the proton is credited to Ernst Rutherford, who proved that the nucleus of the hydrogen atom, i.e. the proton, is present in the nuclei of all other atoms, and he did that in the year 1917. In 1932, English physicist James Chadwick discovered a particle that had the same mass as a proton, but no electrical charge. This particle was called the neutron. So the neutron was discovered less than 100 years ago. Protons and neutrons each weigh about 1,836 times more than an electron. Okay, and that takes care of this lesson on discovering the atom.